In this video, we're going to talk about the difference between compiled languages and interpreted languages. We're going to talk about three languages in particular: C++, Java, and Python. We'll start with C++. C++ is a compiled language. You can see here I have, well, let me clean it up. Okay, so here I have four files: makefile, main.cpp, print.cpp, and print.h. These are source files. My Mac or even a Windows or Linux computer wouldn't know what to do with these files. It wouldn't know how to run them. They're not executable. In fact, I can try it, /main.cpp. It's not going to do anything. It's going to say permission denied, but even if it had permissions to run it, it wouldn't know how to run it. Wouldn't know how to interpret it. So I need to compile this source code into a binary file, a machine code that my computer will understand. And the way I'm going to do that, well, first of all, let's look really quick at the source code here, and we can see it in main.cpp. It's just going to run this function called print, and print goes over here to this source file and runs hello world. So it's just a simple hello world. And so now I need to compile it, and I'm going to use make, which is it's not a compiler. We're just going to use this GCC compiler under the hood, or the G++ compiler under the hood. And the result of running make or compiling it is I have three new files. I have main.o, print.o, and test. Now main.o and print.o are kind of these intermediate files called object files. But the most important file to think about for our purposes is test. Test is a file, it's a binary file, that my computer understands how to execute. So if I do /test, I get hello world. It runs it. It's machine code. So I've compiled my C++ code into a machine code that my computer understands. So now let's go to Python. Here in my Python directory, let's kind of start clean here. I have a file called test.py. And I can look at that, and it's just a hello world program in Python. Print hello world. Okay, so I cannot run this. My computer doesn't understand the source code, but I don't have a Python compiler. There's no such thing. Well, at least to my knowledge, Python is an interpreted language. So I am going to run the file using my Python interpreter by typing python test.py. So what this is going to do is, behind the scenes, it's going to take the source code and it's going to convert it to machine code that my computer understands and run it. So if I do that, python test.py, it ran it, printed hello world, and lo and behold, it didn't add any files. I don't have any files that are machine code. Okay, so that is an interpreted language. Let's look at Java. Okay, again, I only have one source file. If I look at it, it's just a hello world file. And I can't run it again. My machine doesn't understand it. But I don't have a compiler. I have what Java calls a Java compiler, Java C. I'm going to compile main.java into what's called bytecode. So now I have this extra file called main.class, and that is bytecode. That is not machine interpretable code. I cannot run main.class. My machine doesn't understand it. Again, permission denied, but it doesn't understand it. So I need to use a Java interpreter. So I just use the Java interpreter, Java, and I run main, and it prints hello world. Now, you might ask, why do we have this intermediate step if it's just still interpreting it? It's not compiling it really into machine code. Well, it's interpreting it and compiling it into bytecode, and that's useful for optimization while maintaining platform independence. So we have C++, which is compiled. We have Java and Python, which are interpreted.